Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer released in 1991. Last episode we managed to move the camera around using the arrow keys. We managed to smooth out the scrolling and even the backdrop for the level can be seen. So for this episode we will tackle another potentially difficult subject, collision detection. In general, that means detecting whether or not a game actor overlaps with solid tiles or with other actors. Once we are capable of detecting such overlap, we can let the actor respond to this, for example by changing the position of the actor in such a way that it cannot pass through solid blocks. This will be important to have in place for jumping and falling, which we'll cover in a future episode, and of course shooting stuff and picking up items. Let's get into it. Okay, so let's start by adding a class that will hold our hero. And let's give him an X and Y position to begin with. And let's also give him the accelerate function that we also gave the camera. And then we'll add him to the game state as well. And then for now, we'll remove the camera X and Y because we will adjust the camera based on Duke's position. Oh, we need getters again. I always forget about those. There we go. So our camera X is based on Duke's X position, but then this will be the top left of the screen. So we want to subtract a little bit, so to center Duke. So in order to center Duke, we have 13 columns times 16 tile size. That's 208 pixels. If we divide it by 2, that's 104. That's the exact center. Now if Duke has a width of 2 tiles, so let's subtract 16, that's 88. And let's do the same for the Y position. So let's subtract 10 times 16 divided by 2 is 80 minus 16 is 64. We don't need this move camera function for now. All right, so here game state will just obtain Duke. Let's get Duke here. And let's do get Duke dot accelerate delta X and Y. So this will move Duke around instead of the camera. Yeah, and then what we can do is introduce a placeholder graphic for Duke. So let's go with the magenta color here and let's draw a rectangle. And let's state Duke, get X, get Y, and let's assume Duke is 31 by 31, because normally I would say 32 by 32 because tile size times 2, but we don't want to overlap too much tiles. So if we subtract 1, we can be sure that he's contained exactly within those 2 by 2 grid cells. But this X and Y is the X and Y position inside of the level, so we need to subtract the camera position from this as well. So let's do that. State dot get camera Y. Let's subtract those so that the X and Y position for Duke gets translated to X and Y screen coordinates. Okay, so if we run it, then here we can see a nice magenta graphic. And as long as we're not touching any of the solid tiles, I mean, we're still going to be magenta, but what we're going to do now is as soon as we start touching, for example, these solid tiles here, we want to indicate a red color here to show that, okay, we're colliding with the level. So let's do that. So let's introduce an if statement here where we obtain the level from the state and we're going to introduce a collides function in which we will pass the same variables of the rectangle that we just did. And so if we collide, we want to set the color to red, otherwise to magenta, and then draw it. All right, so let's implement this method. So this is a width and this is the height of our bounding box, basically. So let's introduce the Boolean here and let's initialize it to false. All right, now all we have to do, because we are a tile map, for now all we have to do is just go into each of the cells that we need to check in order to cover the area defined by this XY width and height stuff. So we can just start here by saying like, okay, the row is the Y divided by the tile size. So this is where we'll start checking the row, and then we want to check the rows that are smaller than or equal to the cell at the Y plus the height. And this is also why we chose to give Duke 1 pixel less of the width and the height than the actual 2 times tile size, or otherwise we would check too many tiles here in this function. But we will need to come up with a better size for Duke that matches the graphics, but we'll do that later. So yeah, the columns are the X plus the width. And then here we can say like, all right, the tile ID is the tile at the row and the column. And then we need to figure out which tiles are solid. And then if we go to the Duke Nukem modding wiki here and check the Duke level format, we can see that Duke cannot pass through at least these solids here. And there are a few more objects that Duke cannot pass through, like force fields and stuff, which are probably somewhere in these active things. Or maybe here, these hacks. I'm not sure. But for now, we'll just check this range here. And if the tile is part of this range, then we'll assume that we collide with the level. So collides equals tile ID larger than or equal to 0,1800. And then we need to go to 2FFF. So we need to also check that tile ID is less than or equal to 2FFF. We can just do it like this. All right, so the final thing we need to do is, because we're looping here over multiple rows and over multiple columns, as soon as we collide with one of the cells, we want to set this flag to true and never go back to false. Now there are multiple ways to do that, like we could break outside of this for loop and just stop checking altogether, which is probably the most efficient thing to do. But for now, the easiest thing to do is just setting the flag with this OR operator. That basically means that once this flag gets set to true, it will never be reverted back to false, but it will still check each and every single cell. Now, I don't think it's going to be a problem because most moving actors are pretty small. And if we do find ourselves spending too much time in this loop here, we can always optimize it later. I always like to think of, make it work, make it right, and make it fast in that order. So make it fast comes last. So for now, we're just going to try and make it work and hopefully make it right. All right, so now we have a collides method that checks the level geometry for a certain bounding box collision. So that means that if we go back to the graphics, that this function now here works. And I do expect if we do collide with one of the solid objects that our rectangle will start to be red. So let's see if that happens. So let's move down. All right, so as long as we stay in the open area, nothing happens. But let's move across these barrels here, and we can see that our bounding box becomes red. All right, so that means that the collision detection works. So the next part of this detection is to do collision response. And with collision response, we mean to, what happens if you move into this box of nuclear waste. The game should detect this position and conclude that this position is not possible and push you out to this position that is possible. So, collision detection is always thought of, not being able to pass through solid objects, but really it's a two-part problem. First is to actually detect the collision, and then the second part of the problem is to do the appropriate response when colliding with something. So that's what we'll do next. Okay, now the naive way to implement collision response would be to just check if the movement that we are about to do is at all possible. And if it's not possible, then just not do the movement at all. This works while the movement that you do snaps perfectly onto the grid, which does for us at the moment, but it won't later on. But let's just, for sake of demonstrating the argument. So let's separate out the X and Y positions with our velocity. So let's give Duke two separate velocities, horizontal and vertical velocities. And the accelerate function increments the velocity. And then what we need to do is give Duke the update method. Basically allow Duke to update himself based on the game state. So okay, let's grab the level first. We'll need a level. State get level. All right, so int new position x equals x plus velocity x. If the new position x, y, 31, 31 if we do not collide, then x is new position x, and otherwise we do not change x. And we'll do the same with y, new position y, y, velocity y. If x, new position y, does not collide, update the y position. And for now, let's always reset our velocity each update. Here you would introduce friction or, acceleration and deacceleration basically. But for now, we'll just stop moving altogether. So yeah, this will update the X and Y position if these new positions are at all possible. All right, so we need to call this update method from our game loop. So here we have update, and here we say game state get Duke accelerate. And let's just for now call the update with the game state, just to see if this works. All right, so I'm pressing to the right, but I cannot seem to pass through these solid objects. So this collision detection is looking rather okay, which is something I'm pretty happy with. So for now, I think I want to update a few little things. I think I want to separate these into their own private functions. So let me just extract this here, and let's call this move horizontally. And let me just do it with the actual tooling. Move vertically. Okay, and let me just move this below the move horizontal, move vertical. And then once we're done moving, reset the velocity down to 0. All right. And I think the Duke Nukem main class here, I think handling the input here is fine. And I think accelerating Duke based on that input is fine as well. But I do think I don't really like this construction here. Game state get Duke, then update with that game state instead. So what I'll do is I'll go to the game state function itself. And I'll actually give this one the update method as well. And what this will do is this will update all the objects it has here. So this will update Duke. And then it will just pass in itself. And then, for example, if a level is going to have an update method as well, which it doesn't have just yet, we'll call it there as well. So then we can just say here, game state update. And then what we can do is we can rename this to handle input. And then here we can say game state.update, which I think makes a bit more sense in terms of structuring. Now that we can actually run around the level, or fly around the level, I should say, with the arrow keys, and we collide with the geometry of the level, I think the next step for the next episode would be to implement a jump, and then also what comes up must go down. So we'll also introduce gravity. And then we'll compare that to the original game to see if we're in the ballpark with our camera speed, movement speed of 8 pixels per frame. For now, I want to thank you very much for joining me. If you have any questions or remarks, feel free to add them in the comments below. Leave a like if you liked the series so far. And as always, I'll see you guys in the next episode. Bye-bye.